Hi students, in this video I am going to discuss about the differential length, area and the volume concept in case of the spherical coordinate system. So before that I am assuming that you have gone through the basic concept on the spherical coordinate system. In my last video I have discussed about it. If you haven't my last video, so please do watch that, then it will be very easy to understand the differential length, area and the volume concept. Okay. Now, before going into deep, let us first draw the spherical coordinate system. See, this is the spherical coordinate system. And in this spherical coordinate system, this small portion that is shown a red color over here, on this spherical coordinate system, I have considered this small volume, that is red color portion over here. I have considered a small section over here. Okay, and you know that what is theta and what is phi. That is phi is 0 degree over here and phi is 90 degree. Phi is increasing in this direction and theta is 0 degree at z-axis and theta is increasing in this direction, and at xy plane the theta will be 90 degree, right? Now let me denote this section first. See, this is what this is what this is the phi, you know, right? It is the phi, and this is what, this is nothing but the, this angle is nothing but the theta. Okay, now as this is the phi, this will be what, this angle is nothing but the, this is the small section of this phi, this is the small angle at the xy plane, and phi is also in the xy plane, so I can write it as d phi. This is the small angle, very small angle, very narrow angle. Okay, and this is what, this angle, this angle is the very small theta, so I can write it as d theta. Okay, this is the d phi and this is the d theta. I have written it over here. Okay, now the total length, what is this length? Just a minute. This total length is what? This total length is r, you know. This total length is r, you know. Now, if this total length is r, then what will be this? Let me first notation, denote these things. 1, 2, 3, 4 surface. This is the 1 dash, this is the 3 dash, this is the 4 dash. Okay. Now, 1 dash length will be what? Then 1 dash length will be dr, because it is the small portion of this total length r, right? So I can write this 1 dash length as a dr. Okay, so d theta, d phi, dr, everything is done. Now tell me, what is this? What is this section? What is this portion? Means I am talking about this section. What is this section? This is, see this term very carefully, but before going into this, tell me what is this actually. this length. What is this length? See, look at this very carefully. This total is r, right? I have already told this length, that is the rho actually, and rho is equal to what? Rho in case of the cylindrical coordinate system, I denoted it as a rho, and in case of spherical coordinate system, it will be, this is the total length is r, and that produces an angle theta with respect to the z axis, right? This is the r, and this produces an angle with respect to the z axis. So sorry, this angle is nothing but the theta. So what will be this? This will be nothing but the r sin theta. Okay, it will be r sin theta, right? Now, now tell me, what is this? What is this? What is the small portion of the perimeter? The small portion of the perimeter is nothing but, I can write according to the S equal to R theta concept. I have already discussed that concept in my last video. So if you haven't watched it, please do watch that video first. Okay. So what will be this portion of the perimeter then? That is nothing but the S, and that will be equal to r theta, just like as r theta. R means the radius here. Radius is nothing but the rho into theta. Theta is nothing but the d theta here, not the d theta. Here it is the d phi. So I can write it as r sin theta d phi. I can write it as like this. Okay, this is the r sin theta d phi. Now tell me, what is this? Okay, this is the r sin theta d phi, and tell me, what is this? This. What is this? Now, just like as is equal to r theta concept, just look at here. The total length is what? That is the r, and the angle produces by this small portion of the perimeter, that is d theta. So what will be this small portion of the perimeter? That is nothing but the r d theta, according to the r is equal to r theta concept. So this will be nothing but the r d theta. This portion. This is nothing but the, I'm talking about the 2 and 2 3 line. I'm talking about the 2 3 curve. The length of the 2 3 curve is nothing but the r d theta. And remember one more thing. The 3 4 curve, the length of the 3 4 curve is same as the rho d phi, that is the r sin theta d phi. Remember this point. Don't make any misconception about that. Okay. Now, let us first see the differential length. What is the differential length? But before that, let me denote the directions of the r theta and phi also. Now, what is the direction of the r theta and phi? Now look at this. Okay. Let me take a different color for that. See, what is the direction? What are the three directions or the three unit vectors in case of the r, theta and phi? Now, first of all, look at this. This is what? This is the same direction which lies in the direction of the r. Okay. This direction the r also occurs. So this will be what? That is the nothing but the AR. AR means this is the direction of the r. Okay. I can write it as AR. That is the unit vector in the direction of the r, because this length is r actually. Now what is the theta? Theta will be nothing but the, in the direction of theta. A theta will be nothing but the, in the direction of theta. That is what? In this direction. That is nothing but the a theta. Because the theta angle varies in this direction. We have seen over here. The theta angle varies in this direction, in the downward direction. Okay, so that means this is the a theta. Now, what is the phi? Sorry, just a minute. A little mistakes I have done over here. Okay. Now, what is the a theta actually? A theta is in the same direction, but it will be the perpendicular on the plane, right? Just like as this. That is the perpendicular in the plane. It is the a theta. Okay, like this. This will be perpendicular on 3, 3 dash, 4 dash 4. This plane. Okay. This is the perpendicular on this plane. This is the perpendicular on this plane. Okay. Now, what is the phi? Right now, the phi will be in the phi directions. Just a minute. Let me write this r theta here. Now, what is the phi direction? Phi is increasing in this direction. In which direction? It is increasing from x towards y, right? So that will be the direction of the phi. And if it is the plus fi, this will be minus fi. If it is the plus fi, this will be minus fi. And that is also the perpendicular of the on the surface. What is that surface? 1, 4, 4 dash 1 dash. This is the surface of 1, 4, 4 dash 1 dash. On this plane, this minus fi is perpendicular, because to know that the surface vector is always perpendicular upon the area or upon the surface. You know that, right? So I have denoted all the three directions of the r, theta and phi over here. Now let us talk about the differential length equations actually. I think this picture is very much clear to you. You have understood each and every notations, right? Now if you understood each and every notation, now let's talk about the differential length. Okay. So our first is differential length, which is definitely a vector quantity. Okay. Differential length, definitely it is a vector quantity. Now the length will be, differential length is a vector quantity and it is also in the three-dimensional vector space. So as it is a vector quantity and also in the three-dimensional vector space, so it must have the three components in the three directions. And what are those three directions? That those are nothing but the AR, A theta and A phi. Okay. So look at this section very carefully. That is the red color over here. The small portion or small volume very carefully. Okay. Now, as it is a volume, it must have the three things: length, width, and the height. So, and it has the three things. So I can say the differential length for this particular volume, small volume, has the three components along the three directions. So let us see what are the three directions. Now differential length component in the direction of r. How we can write it? See, in the direction of r means these directions. Okay, in the direction of r means this. Now in these directions, what is the small length component? That is nothing but the dr. Dr will be the in the same direction of air. So I can say the differential length component in the direction of r is nothing but the dr. That means dr is the actually the magnitude of the differential length vector and ar is the direction. Okay. So what will be differential length component in the direction of ar is dr air. Similarly, differential length component in the direction of theta. Let us see what is that. Now find the direction of the theta. That is the a theta right over here. Okay. Now if it is the direction of the theta, then I will try to find what is the length in the direction of theta. That is nothing but this length. That is 1 4 or 2 3. That is nothing but the r d theta. So that is the magnitude of the differential length component in the direction of theta. That is in the direction of a theta is nothing but the r d theta. So I can write it over here also. The differential length component in the direction of theta is nothing but the r d theta. Okay. And similarly, what is the differential length component in the direction of phi? Now, first of all, when I'm talking about the differential length component in the direction of phi, then you must have to find where is the a phi or what is the direction of the phi. You can see the direction of phi is like this, is this direction. Okay. So that is nothing but if the differential length component in the direction of phi, this is nothing but this 3 4. What is this 3 4? Or you can say this is this may also 1 2. 1 2 component has it is the line vector in the direction of fi. Okay, because it lies on the same direction, lies on or the parallel with respect to the fi vector also. As it is parallel with respect to the fi, or it is the collinear with respect to of the fi. So that's why I can say this 3 4 or the 1 2 component is the magnitude of the differential length in the direction of phi. So what is that actually? In equation I can say this is nothing but the rho d phi or r sin theta d phi. So differential length in the direction of phi, that's why I am writing over here a phi, that is nothing but rho d phi or r sin theta d phi. Okay, I can write it like this. I'm sorry, r sin theta it will be. R sin theta d phi. Okay. Now, these are the three individual differential length component or the differential length vector in the direction of r, theta and phi respectively. Now, what is the total differential length vector? That is nothing but the dl in the direction of r, then theta in the dl theta in the direction of r, dl phi in the direction of r. That will be nothing but dr in the direction of ar. Then I am substituting the values actually. R d theta in the direction of a theta, then r sin theta d phi in the direction of Fi. So this is the total differential length, and it is a three-dimensional vector. So that's why I have shown the components of all each and every directions. That is nothing but along the direction of r, theta, and phi respectively. And this is the total equation of the differential length. As you can see, it is a three-dimensional vector. That's why it has the three components in the direction of r, theta, phi. Okay. Now let us see the differential area. That is the differential area. Now to understand the differential area, let me draw the coordinates again. So this is nothing but the coordinates of x, y, and z. Okay. And in this coordinate system, I am trying to draw the three areas. What are those three areas? Three areas are nothing but the three surfaces or three exposed surfaces of this small block. I'm sorry, this is not a block. This is the small segment of this total surface. Okay, that is the red segment over here. As you can see, what are those three areas in the three directions? First area is 1, 2, 3, 4. So let me draw this area, that is nothing but this 1, 2, 3, 4, and it has the directional vector of here, which is perpendicular with that area. Now the first area is what? Like this. Now this area is nothing but the 1, 2, 3, 4. Okay, and this is what? Here. Okay. So I can write this area. This is what? It has a particular magnitude, and what is the magnitude? What is this? 1, 4 or the 2, 3? Let me see in the main diagram also. That is the r theta. 1, 4 or the 2, 3. The length of 1, 4 or the 2, 3 element, that is nothing but the r d theta. Okay. As well as the 1, 2 or the 3, 4, that is nothing but the rho d phi or r sin theta d phi. Okay. So this is nothing but the r d theta, and this is nothing but the r sin theta d phi. Okay. Okay. ds is nothing but, there is the magnitude of this area, that is nothing but the r square sin theta d theta d phi. R square sin theta d theta d phi. Actually, r d theta into r sin theta d phi. Okay, for your convention, I am writing this very clearly. See, that is what? R d theta into r sin theta d phi. In the direction of what? AR. Okay, that will be what? That is nothing but the r square sin theta d theta d phi. Okay. Now, what is the another surface? Another surface is, let us see. Another surface is this. Look at this surface. 1 4 4 dash 1 dash. 1 4 4 dash 1 dash, and the surface vector is directed towards the minus fi. Okay, surface vector is directed towards what? The minus fi. So let me draw this surface separately over here. Okay, it is the surface vector. Okay, surface vector is in the direction of the minus fi. Now this surface can be written as, what is the length of 1 1 dash or 4 4 dash? That is nothing but the dr. Look at this look at this diagram. 1 1 dash or 4 4 dash, this is nothing but the length is dr. Okay, so let me write this length here also, that is the dr. Now what is 1 4? See, 1 4 I have already written over here. There is the r d theta. In the main diagram you can also see, that is nothing but the r d theta. So what will be the surface vector? Ds, the differential surface vector or differential area, that is nothing but the magnitude. Magnitude is what? That is nothing but the dr into r d theta. In the direction of what? In the direction of minus fi. Okay, that is nothing but the, I can also write it as r dr d theta, right? I can also write it as r dr d theta. In the direction of what? In the direction of minus fi. R dr d theta in the direction of minus fi. Okay. Now the third surface that we can see exposed in this figure is nothing but this 3 4 4 dash 3 dash. This surface, that is the 3 4 4 dash 3 dash. The small surface is exposed, and not only that, there is the direction vector or the area vector is what? Directed towards theta directions. That is denoted by a theta, right? So I am drawing this surface over here. Actually, this surface looks like this. Just a minute. This is what? This surface is denoted by 3 4 4 dash 3 dash. And this area vector is given as what? The magnitude. What is the magnitude of 3 dash 4 dash or 4 3? That is nothing but what? R sin theta d phi. This is nothing but what? This is nothing but R sin theta d phi. Okay. That has been already written over here. That is the 3 4 R sin theta d phi. In the main diagram also I have also shown. This is this. This is what? 3 4 or 3 dash 4 dash. That is I have been written over here. That is the R sin theta d phi. That's what I have written here also. R sin theta d phi. Now what is 3 3 dash or 4 4 dash length? What is the length of this 3 3 dash or the 4 4 dash? That is nothing but dr. dr. Okay. That is also shown in the figure here. That is the dr. Okay. Now what is the area vector or the differential area? Now definitely this has the direction of a theta, right? Now what is the magnitude? Magnitude is nothing but the multiplication of these two. That is the dr into r sin theta d theta sin theta d phi, or the d theta d phi in the direction of a phi. That is nothing but the I can write it as the organized way. That is what? That is nothing but the r sin theta dr d phi in the direction of phi. This is one of the important formula. These three formulas are important. Basically, these three formulas are for the differential area in three different directions. Okay. One is in the direction of AR, one is in the direction of a phi, and the one is in the direction of, this is nothing but the direction of a theta. Okay. A theta. Okay. This will be in the direction of a theta. This is not phi, this is actually theta. Okay, these are the three differential area vectors for the small segment, whatever we have cut on the spherical coordinate system, right? This is the three differential area. Now let's talk about the last thing left over here. That is the differential volume. differential volume, and that is denoted by the dV. And one more thing you know also, that is differential volume is the scalar quantity. Okay, that is the differential volume. Okay, so differential volume, that is the dV, can be given as, see, all the three length, width and the height. What are these three: length, width and the height of this small portion or the small segment? That is nothing but dr is one thing, another is r d theta, and the third one is r sin theta d phi. These three things, the multiplication of these three things, that is the length, width and height, will give you the what? The differential volume, that is the dr, r d theta and the r sin theta d phi. The multiplication of all these three components. So that is what? Nothing but the dr dot r d theta dot r sin theta d phi. That is nothing but the r dr d theta, I'm sorry, r square dr d theta sin theta, or you can write it as in the better way, that is okay. That is what? That is nothing but the r square sin theta dr d theta, r square sin theta dr d theta. Okay, that is the differential volume. I'm sorry, d phi is also there. R square sin theta dr d theta d phi. That is the differential volume. That is the nothing but the very easy multiplication of all the three components, and it is the important one. Okay, that is the differential volume concept. Now this was all about the differential length, area and the volume concept for case of the um, what the spherical coordinate system. Okay, and that's all about the spherical coordinate system. Our spherical coordinate system is over. In my next video, I will show you a magical trick or magical short trick or shortcut to remember the formulas of all differential length, area and volume in case of any coordinate system. That may be a Cartesian, that may be a cylindrical, that may be spherical, and I will show you a quick analogy or quick table that will help you to determine the differential length, area and the volume in case of the any coordinate system. In my next video, I will tell about that. But for now, that's all for today. Hope we will meet you soon. Right? Thank you.